Hi there, my name is Mrs. Helt, and I'm going to go through the lesson with you on solving proportions. So before we get started, please make sure you have a pencil, your math notebook, and a calculator ready to go. That will help you navigate through this lesson a little bit easier. Also, please, just as a reminder, please check your Infinite Campus portal and check to make sure that you've earned full points on your assignments up to date. If you have a 0 or a 5 on anything, please go back and check to see what corrections you can make or what questions you can finish in order to earn the maximum number of points. So the first thing that we're going to do is try to write an equation for these two situations. We're not actually going to solve them. So I want you to take a moment to go ahead and read those. Try to write your equation. You're going to pause the video while you do that. And then once you have an equation for each one of these, you're going to go ahead and resume the video so you can see how to go through it. So the first one is Matt's Bikes rents bikes for $17.10 plus $3.20 per hour. Alyssa paid $33.10 to rent a bike. For how many hours did she rent the bike? So since we're looking for the number of hours that she rented the bike, we're going to have H represent hours. You could have chose a different variable, but in this case I'm just going to try to use one to be consistent here. So Matt's Bikes is $17.10 plus $3.20 per hour. So when you hear the word per there, $3.20 per hour means it's $3.20 for every hour. So you would multiply $3.20 times the number of hours. Alyssa ended up spending $33.10. That was her total. So we want to discover how many hours she rented the bike for. So this would be our equation right here. If we needed to, we would go ahead and solve that. We don't need to at this time, but you would isolate your variable to try to figure out what the number of hours is. Looking down here, a wise man once said 200 reduced by twice my age is 2. So what is his age? So we're going to start with 200. If we reduce 200, we're taking something away. Twice his age is equal to 2. So I used A to represent the age. So 200 take away 2A is equal to 2. Pretty sure everyone can solve that, but again, you would isolate your variable and try to solve for A at this time. All right, so moving on, we're going to get into some ratios and proportions. A ratio is a comparison between two quantities. Okay, so for example, if we looked at our classroom, we could say that the ratio of boys to girls could be 14 to 15. So we're comparing the two quantities. A proportion is two equivalent ratios. So for example, if I had 2 to 4, we're not going to read that as 2/4 because it's really not a fraction, it's a comparison. 2 to 4 is equal to 4 to 8. Okay, so I know I can think about it, whereas if I were to double my numerator, I would get 4, and if I were to double the denominator, I would get 8. A lot of people like to use cross products when solving proportions. So we simply can test to see that if when we multiply the numbers that are on the diagonal, if they end up being the same number. So 4 times 4 is 16, and 8 times 2 is also 16. So since those two cross products are equal, I know that those proportions are equivalent. Sorry, the ratios are equivalent, and it makes a proportion. So if I look at the next one, it says, where do we see proportions in the world? We actually see them lots of places. So let's try this example. So let's say you're currently traveling. You might have to figure out what is an equivalent ratio, like when you're going to cash in some money. So currently $1 is equal to 21.55 Mexican pesos. The rate changes daily based on the value of currency, but we're going to determine the amount of pesos you would receive in exchange for $125. So my ratio is going to be $1 will give us 21.55 pesos. So this is our dollars. This is our pesos. And I want to know what that's going to equal if I have $125. I want to figure out how many pesos that's going to be. It's going to be X. So you could think about it as, well, if one is 21.55, I know that in order to get 125, I'm going to multiply that by 125. So I could end up doing the same thing with the number of pesos in order to figure out how many I would get for that. So if I go ahead and I do 21.55 times 125, I'm going to get 2,693.75 pesos. Okay, the next question. A rectangle has a width of 4 inches and a length of 3 inches. The figure is enlarged to a width of 10 inches. What would the new length be if the dimensions were kept proportional? So if I have a picture here to represent my situation, I've got a width of 4 and a length of 3. And now my picture is changing so that I have a width of 10. And I'm trying to figure out the length. So that's X. So I'm going to go ahead and I'm going to set up my proportion. And I originally was going to compare the width to the length of each one of these. So when I have a width of 4, I have a length of 3 in figure number 1. And on the second one, when I have a width of 10, I'm not quite sure what that length is going to be, and I'm going to figure that out, and that's X. So since we have X there, we're going to go ahead and we're going to use some cross products here to try to figure this out. So if I multiply 4 times X, I get 4X, and 10 times 3 is 30. So now I just have an equation to solve. I'm going to divide both sides by 4. So X is going to equal 7.5. So in this case, this is going to be 7.5 inches. All right, so we're going to determine if these proportions are equivalent. There's a lot of different ways you could do that. I want you to go ahead and push pause and see if you can determine if they are equivalent or not and come up with at least one way to do that. So hopefully you've had a chance to look at these and determine if they are equivalent or not. There's a couple different ways I can go through that. If I look at the first one here, 2 to 3 is equal to 8 to 12. To go from 2 to 8, because it's proportional, I would multiply by 4. If to go to from 3 to 12, I would also multiply by 4. Since I'm multiplying both the numerator and denominator by the same number, I know that that proportion is equivalent. Now it's not so easy to do that on the second one. I don't have the ability to just multiply the numerator by a number to get 10 easily. So it's going to be a little bit more challenging. So let's also check this out with cross products. If I were to multiply 10 times 10, I would get 100. And if I would multiply 9 times 15, I would get 135. Since those are not equivalent, this is not a proportion. This one here was, yes, a proportion. All right, let's go ahead and look at the next one. So now that we know that you can use cross products to solve proportions, we're going to go ahead and try to do that. So with example 1, we're going to go ahead and we're going to set this up using cross products. It doesn't matter the order that you go in as long as you're multiplying what's on the diagonal. So 10 times y is 10y. 7 times 6 is 42. We're going to go ahead and divide both sides by 10 in order to solve for y. So y is going to equal 4.2. If at any point you need to stop or rewind the video in order to try to understand the concept that we just went through, please feel free to do that. So the next one, we have a variable that's also being added on to here. We're going to go ahead and we're going to solve this with cross products. So 6 times 4 is 24. And I'm going to multiply 8 times the entire denominator of b plus 8. So I'm going to have to do a little distributing here. 8 times b is 8b, and 8 times 8 is 64. I'm still going to solve this like a regular equation. This is negative 40 equals 8b, and I'm going to divide both sides by 8. So b is equal to negative 5 in this case. finally, continue with my cross product thing here. I'm going to multiply 9 times the quantity of n minus 9, and then 10 times the quantity of n minus 1. So I'm going to go ahead and distribute and see what I get here. So I've got 10n minus 10. Then I'm going to go ahead and solve my equation. I'm going to subtract 9n from each side. So this will give me 1n. I'm going to add 10. And that'll give me a negative 71. So n is going to equal negative 71. Alright, so that's the lesson on proportions and cross products. We'll dive in a little deeper as to why cross products actually work, but just realize that we're just trying to determine if the ratios are equivalent at this point and what value would make those ratios equivalent. So now your assignment is going to be to work through questions 1 through 5 on slide 6. That's your independent work. Please make sure you raise your hand when you are finished with that. I hope you have a great day, and please make sure that you are in touch with your teachers if you have questions. Thank you.